To write a quadratic function in intercept form, you are basically factoring. So ignore the y equals, or if you want to, put 0 equals in its place. Take a look at x squared minus 3x minus 40. Do those three terms have anything in common?
No.
Nothing but a 1, so pretty much no. So we're looking for two numbers that multiply to give us negative 40 and add up to negative 3. And again, some of you, this number will pop into your head. Some of you it won't. This one, it actually does pop into my head. Maybe I've done this problem too many times. I don't know. But 8 and 5 pop into my head. So 5 and negative 8. What do you do if those numbers don't pop into your head? You think about 40. You got 1 times 40, 2 times 20, 3 times, nope, 4 times 10, 5 times 8. Once you have that list of numbers, think about, could I add any of these to get negative 3? And that's where 5 and 8 come from. Because this is an ordinary, simple factoring trinomial where there's a 1 in front of the x squared, this factors nicely into x plus 5, x minus 8. They want us to find the function's zeros. Zeros are the same thing as the x-intercepts. It's the same thing as the solutions. It's the same thing as the roots. The x-intercepts happen when y equals 0. So if we put 0 in place of that y, this looks just like the factoring problems that we solved the last time we did this. So if x plus 5 had to equal 0, what would be our x-intercept there? Negative 5. If y minus 8 had to equal 0, what would that answer be? Positive 8. And this is exactly why with intercept form we always took the opposite of the number in the parentheses, because you're really looking for where does this set of parentheses equal 0? It's the opposite of positive 5. So the x-intercepts for this graph would be at negative 5 and 8. The roots, the solutions, the zeros are negative 5 and 8. Now let's take a look at number 9. This time, do 3x squared, negative 12x, and negative 15 have anything in common? 3. This first term, if we take the 3 out, will be plain x squared. Negative 12x, factor out a 3, we'll be left with negative 4x. Negative 15, factor out a 3, we'll be left with negative 5. Now, if we hadn't done that, we would have had to multiply 3 times negative 15, which is negative 45. You have to find two numbers that multiply to give you negative 45 and add up to negative 12. And then even after you did all of that fancy factoring, it still would not be fully factored and it would be harder to solve. Because we took the time to factor out the greatest common factor first, now this is a much easier factoring problem. So we need to factor this part. We need to know two numbers that multiply to give us negative 5 and add up to negative 4. So the parentheses become x plus 1, x minus 5. Technically, we still have y equals 3 in front of those parentheses. Okay, our x-intercepts, our solutions. If this y was a 0, 0 equals 3 times x plus 1 times x minus 5. If x plus 1 needed to equal 0, what would x be? X equals negative 1. And for this set of parentheses, our solution is 5. This 3 does not affect your solutions. We're actually multiplying 3 things together. 3 times parentheses times the parentheses. So if that first set of parentheses equaled 0, 3 times 0 times something would still be 0. That 3 is not going to change what those x-intercepts are. So our x-intercepts are at -1 and at 5. On your worksheet today, a lot of this worksheet is reviewing the factoring that we've done and what we just learned. So 4, 5, and 6 are like the 2 examples we just did. You put it in intercept form and then find the x-intercepts, the zeros, the roots, the solutions, whatever word you want to use for those. On the back side, 7, 8, and 9 are solved by factoring. So you need to get 0 on one side, factor out a greatest common factor if there is one, and then factor and solve. And 10, 11, 12, notice there's no equal sign on those. So your answer should be with parentheses. You should not have x equals on 10, 11, and 12 because there's no equal sign. So you might want to write down no equals. Your answer should be in factored form, not x equals. There is a bonus problem, and I tried to kind of break it up into like what to do first, what to do next, whatever, to help you with the bonus problem. We are going to go through number 1 together, and it's very similar to number 2 and 3. So if you understand number 1, you should be able to figure out 2 and 3. A student environmental group wants to build an ecology garden, as shown. The area of the garden should be 800 square feet. What should the dimensions of the garden be? How do you find area of a rectangle? Length times width. So we have x times 60 minus x, and that area needs to equal 800. So step 1, multiply the two things together and put it equal to whatever area it tells you. Step 2, multiply it out. So if we distribute, we have 60x minus x squared equals 800. We need to get 0 on one side so that we can factor and solve. When you get 0 on one side, you want your x squared to be positive because it's much easier to factor if x squared is positive. So even though it looks like it'd be easiest to just subtract 800 on both sides, we would still have negative x squared. So instead, I am going to add x squared to both sides and subtract 60x on both sides. That will give me 0 equals x squared minus 60x plus 800. Now on 2 and 3, I believe these are set up in a way so that you'll end up with like x squared plus 3x equals 40. Then you definitely would just subtract 40 on both sides, keep your x squared positive. So wherever the x squared is, you just want it to be positive. Move things around so that your x squared is positive. Now we need to factor. So we are looking for two numbers that multiply to give us 800 and add up to negative 60. When you have numbers this big, this part can be a little bit tough. But 20 and 40, I believe, work. And since we're multiplying to get positive 800, that means they either both have to be positive or both have to be negative. Because we're adding to negative 60, they both have to be negative. So negative 20 and negative 40. So 0 equals x minus 20, x minus 40. So then completely ignoring the problem, what are the solutions? The solutions are 20 and 40. Now we have to think about which solutions make sense in this problem. And in this particular problem, they both make sense. But what if we had had negative 20 and positive 40? Would a side length of negative 20 make sense? No. So once you get your solutions, think about, do they both make sense? Could I actually use both of them? If we use 20 in place of this x, this side would be 20 feet. And if we use 20 here, 60 minus 20 is 40. So that side is 40 feet long. If you actually used 40 here, you'd have 40 feet by 20 feet. So no matter which way you do it, this rectangle is 20 feet by 40 feet. So that would be your answer for part A. Part B is talking about perimeter. A construction company donates 120 feet of fencing. Is that going to be enough? So now that you know the dimensions of the rectangle, you should be able to find the perimeter and decide, will that 120 feet of fencing be enough or not? Number 2 and number 3, multiply the two dimensions together, put it equal to the area, get 0 on one side, factor, solve, find the dimensions of the rectangle. 4 through 6 are review from what we did today, the new stuff from today, and then the back side is review.